How it works. Flight is a remarkable phenomenon that allows objects, including birds, insects, and human-made aircraft, to defy gravity and move through the air. The principles of flight are grounded in physics and aerodynamics, and understanding how flight works involves exploring the forces that act on an object in flight, the design of wings and airfoils, and the mechanics of propulsion. The fundamental forces involved in flight are lift, weight, thrust, and drag. Lift is the upward force that counteracts the weight, the force of gravity, of the flying object. Thrust is the forward force that propels the object through the air, while drag is the resistance force that opposes thrust. Lift is generated by the wings of an aircraft or the airfoils of birds and insects. The shape of a wing or airfoil is designed to create a pressure difference between the upper and lower surfaces when air flows over it. This shape, typically curved on top and flatter on the bottom, causes the air above the wing to travel faster than the air below. According to Bernoulli's principle, the faster-moving air on top creates lower pressure, while the slower-moving air underneath generates higher pressure. This pressure difference results in an upward lift force. For an aircraft to achieve liftoff, the lift force must exceed the weight of the aircraft. This is accomplished by increasing the speed of the aircraft along the runway, generating enough lift to overcome gravity. Once airborne, maintaining steady flight requires a balance between lift and weight, as well as between thrust and drag. Thrust is produced by engines in aircraft. In propeller-driven aircraft, engines turn propellers that push air backwards, creating a forward thrust. In jet engines, air is sucked in, compressed, mixed with fuel, and ignited, producing a high-speed exhaust that propels the aircraft forward through Newton's third law of motion. For every action, there is an equal and opposite reaction. Drag, the aerodynamic force that opposes thrust, is influenced by the shape, size, and speed of the aircraft. Minimizing drag is crucial for efficient flight. Streamlined designs help reduce drag by allowing air to flow smoothly over the aircraft's surface. In addition to these basic principles, modern aircraft are equipped with various control surfaces to manage flight dynamics. Ailerons on the wings control roll, elevators on the tail control pitch, and the rudder on the vertical stabilizer controls yaw. These controls allow pilots to maneuver the aircraft and maintain stability during flight. The principles of flight apply to both fixed-wing aircraft and rotary-wing aircraft, such as helicopters. Helicopters generate lift through rotating blades, or rotors, that function like spinning wings. By changing the angle of the rotor blades, helicopters can achieve lift, thrust, and control their movement in any direction. Birds and insects achieve flight through similar aerodynamic principles, but rely on flapping wings to generate both lift and thrust. Their wing shapes and muscle structures are adapted to create the necessary lift and thrust for flight. Understanding flight involves not only the physical principles and mechanical aspects, but also advancements in technology and engineering that continue to improve the efficiency, safety, and capabilities of aircraft. From the Wright brothers' first powered flight to modern jets and advanced drones, the study of flight remains a dynamic and evolving field. In conclusion, flight is a complex interplay of forces and aerodynamics. By mastering the principles of lift, thrust, weight, and drag, and utilizing advanced engineering and technology, humans have harnessed the power of flight to explore and connect the world in ways once thought impossible.